So, on our last episode, I'm going to open up Unity, even though we're probably not going to start with Unity. We got a cube moving left and right. You hit play, you can move it left and right with the keyboard. It's all cool like that. We're going to be doing more work on this episode, but first we're going to install some version control software. We're going to be using GitHub to store these files.
Apparently there's a Gitbox client available, according to the comments.
Yeah, there's a few different clients. We're going to be going with SourceTree because it's the one that I hate the least out of all the Git stuff. Most software choices I make are software that I hate the least. Unity is actually one of the few pieces of software that I actually legitimately like. So, and even it I have to get ire at occasionally. So what we're going to do first off is I'm going to start downloading SourceTree. Now, right. I don't like the latest version of SourceTree on Mac, and I'm not sure if I dislike the one on Windows because I'm not sure if it's the same version, because the latest version on Mac is like 1.9.1 or something, and the latest version on Windows is like 1.5.1. And the one we're going to download is like 1.8.1. There's a lot of .1s involved for some reason.
Yeah, there are a lot of .1s.
So the reason I'm doing the latest one is I just don't like the layout of it. You're welcome to use the latest version. I'm sure it will have many similar features, but the process will be slightly different to work with it. Go ahead and go with your gut on this one. But if you want to get the old version, you search for SourceTree old version Mac. You go to the SourceTree for Mac 1.9 out now, SourceTree blog. And then you go scroll down until you find all of the people complaining about the new interface, and you'll find a link to the old one right here. Oh. So I'm going to click that and download 1.8.1. So yeah, hopefully we're going to download that one. I'm going to turn off auto updates, and while that's downloading, we are now going to set up an account on GitHub. So GitHub is a repository place where you can just put stuff up there. It costs $7 a month for the most basic plan. There's also a free plan. We're going to be using the free one. The trick with the free plan is it only allows for public repositories. So anything that you put up there, the world can download, which is actually advantageous in our case because we want you guys to be able to download this project.
Yep.
But it might not be advantageous in your case if you have the next big idea and you don't want anyone to know about it before you unleash it on the world.
Yes.
So we're going to pick a username. I'm going to call it Make a Game Now. Yay! We're still good. Wow! We've been lucky so far. I know. At some point, someone's just gonna be like, "I bet he's gonna use Dropbox next," and they're gonna register it just to make us cry.
Hope that's not the case.
All right. So our email is main@makeagamenow.com. Create a password.
Wow.
Yeah, I have really good passwords with a lot of M's in them. So, welcome to GitHub. You've taken your first step into a larger world. Very nice Star Wars reference. Evidently, I now am an @ person again. I guess it's like Twitter here. We want free. Is there someone at the door?
No.
That was creepy.
It was creepy.
The door just went...
It was like...
So, chosen. Help me set up an organization. No, I don't care about the organization. Finish sign up. All right, so we have this GitHub thing, and we have no repositories. I'm going to create a new repository. So what version control is and what Git is Git is a type of version control. Version control is a concept where you keep track of all the versions of your files always, so that if something goes dramatically wrong, you can go back. It also allows for multiple people to work on the same project and change files, put different files in, take different files out, and just generally build the project up. So
all sorts of fun.
We're going to call this Make a Game Now. What do we want to call the repository for this? So you just called it Make a Game Now, right? Well, Make a Game Now.
Yeah, I think that's a good name.
All right. Make a game now, make a game now. We're going to make a game now.
When should we make a game?
So anyone can see the repository. You choose who can commit. That's perfect. I probably can. If I click private, it's probably going to be like, yeah, upgrade my account. Right in line. That's nice of them.
Yeah.
So it was public. Description is going to be Learn how to make a game from start to publish from scratch. www.cookingwithunity.com. And initialize the repository with a README. Let's go ahead and do that. I like that. So we're going to create a repository. Oh, is there a git ignore? Do they have one for Unity here? Oh, sweet. We're going to click that. So git ignore means that it'll ignore certain files, and Unity is... we'll find out if it actually works right, but it hopefully will make it so that it only checks in the files that we want checked in. So we're going to do create repository. And first thing I'm going to do is I'm actually going to look at this git ignore file. I'm just curious. So it ignores... Okay, so it ignores library spelled with a capital L or lowercase l, temp spelled with uppercase lowercase temp, obj, uppercase or lowercase. So anything in those directories it will get rid of. And it gets rid of all these extra files that you don't want added. All right, this actually looks clean. It's not exactly what I would use, but we may modify it later. But this will be good for a start. So let's see how that download. The download's still going. So while that download's going, let's open up Unity and mess around with it.
All right.
Open project.
And when are we going to make a game?
We're making a game now.
Right now?
Now?
Make a game
now.
Right now?
.com.
Right
Make a game now.
Right now.
Right now. All right.
Holy crap.
Yeah. So
just got real.
So I'm going to double click this and wait for...
I registered an account on LiveJournal with the username Make a Game Now. I'll sell it to you for $100,000.
All right. Well, if the Kickstarter is 100,000 over at least, I'll consider it. Maybe, but like that's not really how the money works because we kind of want that to go into the game.
LiveJournal.
So I really don't want LiveJournal, but yeah, that's pretty good. All right.
There's a question if we're gonna enter Ludum Dare.
Ludum
Dare. Is it Ludum Dare?
When does it start? I think it's actually Ludum Dare, but everyone pronounces it Ludum Dare.
I'll look that up.
It's Latin. It should be Dare. So, but I don't think people care.
No,
so.
I don't think people do. 17 days, 21 hours, 20 minutes, 21 seconds.
All right, yeah, maybe. That's right at the end of this thing, so we'll see. If the Kickstarter is successful by then, yeah, sure, probably.
Yeah.
If it's not, then I'll be doing other things like writing resumes. So why is
hope that that's not the case?
Okay, so we've got this thing, move left to right. We hit play, we can move left to right. That's one thing. Now, I haven't really told what type of game we're going to be making yet, and it's partially because we're going to kind of be making a couple of games, like game-ish things, just to show you some basic Unity concepts first, and then we're going to make the game.
Yeah.
So we're still in Unity concept land right now. So one of the things I want to show is, one of the common things you do in games is you spawn something. You create an object that was not previously there. Like, say, when you are playing Space Invaders and you hit shoot and a bullet goes up. You've got to create a bullet somehow. So I'm going to show how to instantiate an object using code here. So we're going to create a new C# script, and we're going to call it shoot. Shoot. And I'm going to do my standard thing where I move these to the next line. In C# and actually most programming languages, they're white space independent, so you can have as many spaces or tabs or whatever you want.
It's a lot of personal preference.
Yeah, like you could say foo times 10, or you can do, well, not fun. Why did it? Okay, whatever. Foo times 10, or you can put spaces between them or whatever. So don't worry too much about spacing. And if you want to space things out more, that's great. If you want to space them out less, that's great. I like kind of an in-between where it feels like I've got some room to work with. Most of my scripts I try to keep as simple as possible anyway, so it works nicely to kind of encourage that because I'm going to be using a lot of space if I'm doing a complex script. So we're going to create a couple variables right off the bat. So we're going to do public public game object bullet. We're going to do a public, let's just do the bullet for right now. And what we're going to do is, on update, we're going to check to see if the user has pressed a button. So we're going to make an if statement. We're going to type in if with a parenthesis. We're going to say input.get button down fire1. Now, remember in the last episode we looked at the input manager, and fire1 is one of the default inputs. So if we can just use this right now, and it should just work. And it's trying to help me it's trying to be helpful and
I'm trying to help.
Move things around in ways I don't like. Why is it putting all of these spaces everywhere? So, again, the spaces can be there or not. It's up to you. So, if it get button down. So, basically, if the code comes to here and it's like, okay, this object needs to do something, it'll be like, oh, if get button down, fire, and no one's pressing fire, then it will just skip this and nothing will happen. So, perfect. So, what we're going to do is we're going to instantiate our game object, which is called bullet. And we need to give it a position, so we're going to use transform, lowercase transform dot position. So that's the position of the object this script is attached to. And I'm going to use the rotation of the object as well. So we're going to use transform with the lowercase t. Why is it doing this to me sometimes? Escape. All right. Dot rotation. All right, so all this will do is if we push the button, it should make the bullet. So I'm going to attach this to our cube, which is our player, and I'm going to hit play, and I'm going to hit the left control key, which is the default for firing. And you'll see that it says unassigned reference exception. The variable bullet of shoot has not been assigned. That's strange.
The variable bullet of shoot?
Yep, the variable bullet of shoot has not been assigned.
That makes sense.
So if you double-click on this, it will actually bring you to the code where the error happened. So it happened on our instantiate call. And we actually wrote the instantiate call correctly, but what happened here is we have this variable called bullet, and we haven't set it to anything. And it's actually difficult to set things to a default in the case of game objects. Just bear with me on this, it's because it's a reference. But if you go to inspector here, you'll see that the shoot script has this bullet thing, and it says none, game object. So it needs to have something there.
Object reference not set to an instance of an object.
Exactly. So what we're going to do is we're going to create a sphere. This is going to be our bullet. And I'm going to just move it out so you can see that it is indeed a sphere. It was inside of our cube. And we're going to just drag this sphere over into the right. And what this does, you'll see it turns a little bit blue here. And you'll see that it now says sphere over here. This is a prefab. This is in Unity, a object that you've configured that is not in your scene, but you could instantiate at any time later. Mm-hmm. And so you can just drag these in, so you can have a bunch of them in the scene. So we can just drag a few in, move them to different locations, and you can change all of them at once. Like if I turn off the mesh renderer on the prefab, all of them will change. You can also individually change things, and if you change those things, it usually makes them bold to let you know that they changed from the default. It doesn't unbold them when they go back to their effective ones, but whatever. It's cool that it at least tries. So I'm going to delete all these spheres from our scene, so there's none in the scene, and we just have this prefab. And we're going to click on the cube, and we're going to drag our sphere prefab into it. We're going to hit play. So now if I hit Control, you'll see that a sphere with a clone came in here. Now we can't see it because the cube's in front of it, but if we move, we can see that there's a sphere there. So now and if we hit Control again, we've got a sphere there, we've got a sphere here. We can just keep hitting it and many times as you want. It's like painting with except for only in a line and with spheres.
Just pooping out spheres.
And each of those spheres actually has a huge number of polygons.
Yes.
That's the other difference between painting and this. So that's great. We just created an object, but we wanted it to shoot. We wanted it to go somewhere.
Yeah.
So what we're going to do is I'm going to split this up into two separate scripts. We're going to have the shoot script just make things, right? And so it really shouldn't probably be called shoot, but I'm going to stick with it for right now. But we're going to have a script on the bullet that tells the bullet how to go. And actually, we've already got a script called move, and I'm going to modify it so that it's a little bit more flexible so that we can use this for our sphere. So you'll notice I try to keep things very simple in the naming. I like to keep scripts as open as possible so that we can use them in multiple ways. Like even I mentioned that shoot's kind of a bad name because that's not technically what it does. It should be called spawn on button or something. And we might even change it. We might even change it later. But so if you keep it as generic as possible, all of a sudden you'll have this set of Legos as you build these scripts, and you can just start piling these onto your objects in however ways you want and create interesting situations with them. So our move class, we're going to add some variables to it. We're going to do public vector3 direction equals vector3 dot forward. So what this will do is it will create a vector3 that we can change in the editor, and it will default it to z equals 1 and all the other ones are 0. Working off of Z works better in Unity. As a best practice, you want things to be moving primarily on the Z-axis. The reason being is all of the quaternion functions, quaternion is a big word, but it's basically for rotation stuff, are kind of built around forward being the main direction. So this works to our advantage by doing it this way. We can, of course, make it move in other directions by changing this variable, but a good default is vector3 forward in this case. We could have it so this determines the speed as well. I'm actually going to have speed as a separate variable. Public float speed equals 1.0f. All right, so we're going to save this. I'm going to get rid of this stuff that we don't need anymore. And what are we going to do? So transfer dot position plus equals vector3 dot right times time dot delta time. We're going to change this to be plus equals direction times speed times time dot delta time. So all this means is go in the direction times the speed times it per second. This just basically means per second. Even though it's a multiply there, it effectively is a divide because this is almost always below 0.
Yeah.
If it's above, not below 0, it's almost always below 1. If it's above 1, you've got a frame rate problem. So seconds per frame is a bad thing to be in. So what are we going to be doing here? So we've got this move thing. We can give it a direction. And actually, I'm going to do one more thing here. Instead of just doing direction, so as I mentioned earlier, vectors have direction and magnitude. And we could use that magnitude to determine the speed instead of using the speed variable. But if we call it a direction and we don't want to use the magnitude in there, we can get rid of the magnitude by doing dot normalized, which will make it a 1-unit vector. So I could set the vector to be like 5 in the Z, and I could set the speed to 5, and instead of going 25 in the Z, it will just go 5 in the Z. It will just pay attention to the speed. So I'm going to go with that. This is a slightly costly operation. It's not going to be... The thing is, on computers and even on phones and even on bad phones, the math is usually not where you're getting killed in this stuff, unless you're doing some really fancy math or some really stupid math. I guess you could do some recursive like craziness and break things real quick.
Oh yeah.
So now we have move. So we're gonna attach move to our sphere prefab. And what are we going to do with it? So we've got direction Z1. I'm just going to leave that. And we're going to make the speed 10. Actually, let's make it 15. Let's make it real fast. And so now if we hit play, when we shoot, you can see that we are now shooting into the screen in the Z direction.
Nice.
Which is actually kind of cool. We could make a little Z forward game. We might actually make a Z forward game. So... we're still debating on what the actual game project is going to be. So we can shoot off into the horizon there. Now,
I think they're onto something here. A dating sim about dating deceased U.S. presidents.
Wow. Can we do that as a 2-button game?
Yes and no.
Do you want to date this president? Yes, no.
Yeah, and then it would just be like, buy him pretty flowers.
Yes, no. And then you can run out of money.
Yeah.
So you have to start saying no more often.
Yeah.
You can gray out the yes.
Yeah, and then that crack addiction.
We're not doing
probably,
that.
No.
We're not doing that. All right. So right now we're shooting into the scene, which is actually super cool. But let's say we wanted to shoot up. Now, we could change it so that it
Whoa.
moves up on... Oh, yeah. We could change it so it moves up on the Y. So I could just change it to Y, and if we hit play, it will shoot upwards. But I actually recommend generally staying on the Z. And what's nice is, in our shoot script, you'll notice that it takes our current transformed up position and our current transform rotation. And so what that means is we can actually just rotate the cube to change the direction that it fires. So if we rotate this cube 90 degrees on the X, so that the blue is the Z, is pointed straight up, so negative 90, and hit play, you'll see that we are now, well, we're not. You won't see that at all.
Oh.
Did I not change? Ooh. Messed something up. So... shoot, move left and right. If I hit play and I go to the scene, it's still pointed up. I hit shoot. Oh, I know what you did wrong. Alright, so this direction, so we don't use our rotation at all here.
No.
On the not on the move script. We're using just the direction. Alright, I'm actually going to get rid of the direction because it's going to confuse people too. Let's do it. Whatever. Let's do a little quaternion multiply. Why not? What?
One button equals flirt and the other button equals vote.
Wow. Alright, this is going on the ideal list. This is, not for this series, but
Yeah,
dating
that's
dead
amazing.
presidents might be pretty amazing. So what's happening here is we're just using the direction, so we're not actually using our rotation in this equation. We can actually use our rotation by multiplying, I think on the left-hand side, we'll find out, transform.rotation times these things. And I'm going to go ahead and put this in brackets as an order of operations thing because I don't really trust what that would do without doing that.
Yes, I would agree.
So let's see if this compiles. It might not. It might be right side that we want. No, it looks like it compiled. Let's see if it works. If we hit play and shoot. Yep, it's working. Yay. Let's double check. I just want to make sure our sphere is going Z. Yep, it is. So if we do Y on it, it'll now break and go probably towards the screen. Let's see. Yep. You can just hit ourselves. And sometimes it switches because I've got control as the attack button. I'm probably going to switch that at some point so that we don't keep switching screens.
Back to Z.
So I'm going to go back to Z.
You're going to rotate the
And
cube.
we are now shooting straight up. Not shooting up, shooting straight up. So I'm going to save scene, save project, and quit Unity for right now, because I think our download is finished. Wait, did I already have... I already had downloaded, didn't I? Well,
Apparently,
oh well.
yes.
I had prepped for the episode, and I didn't even realize it. So, whatever, we'll open the new one, because it's fresh. And
So fresh, so clean.
we install it by just dragging it into applications. On Windows, it'll probably be an exe, hit next, finish. You know, and actually, sorry. Make sure there's not a toolbar in there. If there's like a check mark, install this
That
stupid
says-
toolbar. Uncheck that, and then hit next,
Anything
next,
that's asking
next,
you about
finish.
the Ask toolbar, you want to say no.
Yeah. Can you believe Microsoft did that on DirectX? Can you believe that when you install DirectX,
it
it
sets
tries
a-
to install the Bing toolbar?
It sets a terrible precedent.
Yeah, terrible. All right, so it's installed. We go into applications. We're gonna go into SourceTree, and we're gonna open it. And I agree to the license agreement. Our email address is main@makeagamenow.com. Next. So this already supports Bitbucket, Stash, and GitHub. All these are built-in like social versions of Git.
Mm-hmm.
So we already have a GitHub account, so let's use that. Make a game now.
Password?
Password Mimi. Login required. I did that. Or is it? Did that work? Okay, find local repositories. I don't care. We don't have any. Help improve secure SourceTree by sending data about your usage. Yes, I want them to know I'm using the older version. And as a matter of fact, I want them to know... No, not what I wanted. Opposite of what I wanted. Preferences, update. Oh, good. It already says no. Perfect. All right, so we're going to add a repository. We're going to click the little web icon. I think that's supposed to be a world. Yeah, you can see the little US in there, I guess.
There it is.
And make a game. There it is. It shows up because we already signed in with our stuff. So we're going to just hit OK. I guess we could have created a repository through this as well, but it brought up the interface, so why not? So hit clone.
Clone.
And where is it actually going to put these files? Oh, it just puts them in
Your users.
My user. So make a game now in my home directory.
No, that's not a bad place
So
for it.
yeah, it's not. That's where we'll put it from now on. So so let's go ahead and add our files into it. What we're going to do is we're going to get rid of this README file. Actually, let's look at this README file, because I think this README file is also used. Okay, yeah, this README file is used by the repository, I think, for the description.
Interesting.
So we can add some additional info. I'm just going to leave it in there.
Yeah.
What did I want to do? There was something I wanted to add on this. Whatever. We'll worry about that later. So I'm just going to grab this whole thing, and we're going to put. Oh wait, before we do this, we're going to open Unity again, and we're going to prep for version control. We're going to click Make a Game Now.
Keep seeing these funny comments. Wow, that's a new one. An OS maker making malware for its own OS. Then the next comment says, "You heard of Internet Explorer?"
This is true.
Yeah, touche.
That's good. That's good stuff. I still like the picture of Firefox and Chrome as like little kids beating each other up with Internet Explorer like off in the corner eating glue.
Yeah, I like that one.
It's a good picture. Too. So what am I doing? So we've got what are we doing? So in our project settings, if we go to Edit, Project Settings, Editor, there's some important things that we can change that are helpful if you're using version control. First of all, it hides your meta files by default. Meta files have additional meta information about the files that you have in your project. It hides them. I actually like them to be visible. I like them to know that they're there. I haven't seen that one.
You haven't seen this one?
No, I'll have to look at that in a bit here.
Yeah, we should put it up.
So I'm going to switch it to visible meta files. And asset serialization, we're going to set to forced text. This means that all the stuff that's like Unity-based, like these asset files, instead of being stored in binary format, they're stored in a text format, which is nicer for GitHub and for Git. So let's go back to our settings, project settings.
Now we have an idea for an endless runner, which you have dating
Graphics.
deceased U.S. presidents, which you can shoot in. The rest of the story is your choice.
Okay.
So a 3D runner dating simulator.
Okay.
About dead presidents.
We'll consider it.
Okay.
It would be they're okay. So the fun thing about that is presidents, their likenesses are public domain. So we actually can put pictures of dead presidents in a game,
Abraham Lincoln,
without any problem. Well, Abraham Lincoln, he'd be expired anyway by a copyright. But
Yeah.
we could put Clinton in a game, no problem.
Oh, that's a good.
There's actually nothing that says that we can't. So. We can put an actual picture of his face in the game, and it will be fine.
That's amazing.
So, asset serialization, forced text. So this is just better for version control. If you don't change these options, it's not the end of the world, but it will work a little bit better if you do. So if you hit save, save project. So visible meta files, forced text. This one's entirely optional. This one just makes version control a little bit nicer.
Yeah, because it's text.
Yeah. It does make your files a little bit bigger, though. It doesn't affect your final file size for publishing, though. It only is your local file size. Yeah. So, hopefully... So, we're going to do... so, with those settings set, we only actually need the assets folder and the project settings folder in here. Everything else can be generated by Unity. I'm going to keep that other stuff down there just in case I'm lying to you and it doesn't work. But I'm 99.9% sure. So you'll see that this says 37 with a question mark here. If we double click this brings up our repository view. And we're not going to be using all the buttons on this thing. Don't get scared by the buttons. But trust me, this is not much nicer than working in command line. I could teach you how to do this in command line, but I think that the current generation of people making games probably didn't grow up with command line, and you probably don't care. Like, it's something to learn. I definitely recommend learning command line stuff at some point in your life, but let's not worry about it for this show. So, So we've got all these files. These are the files in the working tree. So these are things that have changed, and they're all question marks because they're like, I don't know what to do with this file. So we're just going to select all of them. I'm just going to hold Shift and click the bottom one there, and then we're going to drag them up here. And this means that we're going to add them. This is the staged files. So we've staged them, and we're ready to send them up. So we hit Commit, and I'm going to check mark the push commits immediately to origin. If you're working by yourself and you're not doing much complex stuff, you generally want to just have that checked. It'll just make sure that whatever you commit goes to the server. One thing that's kind of cool about Git is you can actually not have an internet connection and still commit files. It commits them to a local place, and you can still go back to their versions and forward and stuff. So it's actually kind of flexible like that. On the show, we typically have been using Perforce. I actually still like Perforce better, but there's some things in Git that are really cool. Git is also very powerful, though, and with great power comes great responsibility, as Spider-Man has taught us so many times.
Oh,
and
Uncle
everyone
Ben
else
likes to say that, yeah.
And so
he's not making his rice.
the thing is, Git is powerful. You can mess things up. You can mess up your own repository. You might have to have a process. What I'm going to be showing you is basic merge flow. If you're working at a company, they might use rebase flow rather than merge flow. There's like different people use the tool in very different ways. Different teams use it different ways. This is just one of the ways. So keep that in mind. So commit message. What we're going to be doing is initial commit. I'm just going to call it that. You should always have a description that's somewhat useful, so that you know what you did. So if you go back later, you're like, oh man, stage 3 like messed up really bad recently. You go in, it's like, I just messed up stage 3. I probably wouldn't say that, but I just added like a monster in stage 3, and it's like, well, stage 3 doesn't work anymore, dude. So, and then you can go back and find it. So
try to figure out what changed.
I'm going to hit commit. It's going to send these files up into the network. Okay, I'm going to click always allow, I guess. Computers. And now, if we go to our working copy, if we go to master, you'll see that we have initial commit. Actually, we have 2 initial commits. Evidently, they called theirs the initial commit as well, which is actually probably more accurate because ours is the second commit. But, oh well.
Yeah.
Evidently, they can have the same name, so don't worry about it. So great. We've got this stuff on the server. You guys probably can access this publicly now, too. So if you just go to... We'll put a link somewhere at some point. So I'm going to quit SourceTree, and we're going to open up Unity again. And our project is missing. And the reason it's missing is because we moved the files in here, and it actually looks to see if there's an assets and project settings. And if it doesn't see them, it's like, that's not a project, and removes it from the list immediately. So we're going to give it our new location. You can just drag this in, and it should show up here. If not, you can click Open Project and use your... Oh, wait, no. There's another button that you could have clicked. Open Project is just whatever's selected, but you could. There's a browsing thing, too, if you're not comfortable with using your operating system to find it, or vice versa. All right, so we're back in here. We've got version control set up. We're going to be doing this for about another 30 minutes. I try to keep the episodes about an hour long. The first couple ones I did shorter just because I wanted to kind of block them out. And that's part of the reason that I didn't schedule all the ones earlier. I'm going to actually have a schedule for the next 5 days at least set up shortly. And it's going to be probably 6:30 for one episode, 8:30 for the next, and 10:30 for the one after that.
Oh, wow.
And Phil, you're welcome to join in on any ones that you can or want to. I know that you've got busy work schedules, so
yeah, typically I do.
So
I'll see what I can do.
I'd love to have you. We love you here.
See what happens.
Makes it so I'm not talking to myself too. It makes me feel a lot better. So if we hit refresh actually on this, let's just see what we got up here. Yeah, see, we got assets and project settings. And like someone could just be like, download zip, and it will just download a zip of everything we got there. They don't even have to have Git installed or anything. So we got
pretty cool.
It's nice. It's nice.
Pretty cool.
Yeah.
Now, when you the next time you commit, it will not have all the Unity generated files, or it will?
It should not. Let's find out. That's a good question. So what Phil was mentioning is we've got these Unity generated files I mentioned, like all these things here. Remember I said that Unity would regenerate them? Well, if we go into our make a game now, you'll see it didn't regenerate all these because we didn't open mono develop, but there is a library file here now. It just magically appeared. Unity did that for us. Now, when we go into version control, if our git ignore is set up properly, sorry, not git, SourceTree, and actually I'm going to add that to my bar. So it's there. So if we go into SourceTree and go working copy, it shows that nothing has changed. So that's good.
Perfect.
That means that everything's working exactly right. Because even though some files have changed in there, we don't want to version those files because those files actually change depending on operating system, depending on a lot of different things. You can sometimes just get away with, like if you zip it up, like if you're working with someone else and you just zip up your project directory and give it to them, it's probably going to figure it out. But it may re-import in the background. You technically don't need to send all that extra data.
Yeah.
And what's nice is Unity now just does this automatically. There was an older version where you had to change a setting, and then there was an older version where the basic version didn't allow you to change that setting. So I'm very thankful that those days are over. So we're going to quit SourceTree. Actually, I'll just leave it running. I'll put it on pane 4. All right. So open up Unity again and make a game now. And what we're going to do is... what should we do next? So let's do a little bit of collision. Let's show some collision stuff. Things can collide. Things can have colliders. By default, the cube has a box collider, and the sphere has a sphere collider, and that means that they can actually collide with each other potentially. Now, by default, they don't because you need to have a rigid body component so that they actually have physical effects. And you also need a rigid body control component to actually detect collisions, even if you don't want those effects. So, what a rigid body is in simulation speak, a rigid body is a mass that has a body that cannot be deformed in any way. It is rigid. So, like, our cube is rigid. It's a very common thing. It's very simple to calculate. Not simple, but like... From a computer standpoint, it's very easy to calculate rigid body physics. Soft body physics is much, much, much more complex. And so rigid body just means what the physics system wants to move an object around. Some of this will start to coalesce as we get further into the series, but you're just going to have to bear with me for a moment here. So we're going to add a rigid body to the cube and a rigid body to the sphere, just to see what it messes up. I just want you guys to see it. So... physics, rigid body. I'm not going to change any of the settings on them. So first of all, when we play, our cube just fell. And the reason our cube fell is because our cube has gravity. It says use gravity here. So we're going to make it not use gravity. And then we're going to hit play. And we're going to shoot some things. And you can see that we're shooting things, although our cube is kind of getting messed up by it. And it's because it's briefly colliding with the sphere inside of it. Actually kind of looks cool. And there's our spheres falling back from gravity. Some of the early ones. None of the other ones are like flying off there. These never actually go away. They just go forever.
Yeah, they do.
Woo! So now we have a game where we can only move left and right in world space, and it's horrible. So, in most games... you actually don't need a physical response for everything. Now, if you're making like a 3D shooter and you want things to blow off of walls and stuff, that's where your physics are important. Mm-hmm. If you're making a platformer, you might want physics instead of rolling your own for jumping and stuff. The games we're going to make are probably going to be simpler than that. We actually just want to know if something's collided. So we can use isKinematic to make it so that they don't move based on collisions. So I'm going to set isKinematic on both the sphere and the cube. And if we hit play, it'll act as if nothing has changed. Everything's exactly the way it was before.
But now we do actually have physics on these spheres.
But now we have physics on these things so we can detect collisions. Why that's important? Let's blow something up.
So, are the spheres being affected by gravity right now?
They're not. I turned off gravity. But even if gravity was turned on, with isKinematic on, they will not be affected by gravity. Yeah, as a matter of fact, honestly... they should change this interface so that it grays out everything when you turn on isKinematic.
What about for the bullets, the projectiles?
For that... oh, yeah, sorry. Yes, I did on both, so...
okay.
But yeah, if I turn on gravity for this, it will not fall because it says isKinematic, which is hard to understand why it's going on. And kinematic sounds like it's moving. It's kinematic, but it actually means that you're moving it, not the system. So, so what are we doing? we're going to create another script here.
Is Git the way to go for a free Team Unity setup, or is there a better way?
Honestly, I like Perforce, and I have a video on how to set up Perforce on Amazon AWS, but it's not free because you need to have a server, and the AWS server will cost you about $10 a month. For free, Git's pretty good choice. SVN is also a good choice. There's a bunch of free repository systems for both of those. In both cases, you can shoot yourself in the foot and you can shoot your partners in the foot. So just learn kind of how the system works. Mm-hmm. Play with it a bit. Like before you commit your baby to these things, like play with things, figure out how things work, then start using them. Yeah. Like it's safer. I'm always going to suggest experimentation because there are things that are easier to learn experimenting, and there are things that can only be learned experimenting. And yes, you can learn the wrong way experimenting, but you can also learn the wrong way reading things. So especially these days with the internet. So experimentation gives you, like, if you have something that takes 4 tests to learn, do them. Like if you're like, oh, what does this check mark do? It's a check mark. Check it.
Yeah.
You know. So, and that applies to source control and everything. But Perforce is what we use on the primary show, and so if you want some experience with that, our other episodes will be using that, and we have an episode on how to set that up. Git will be using on this series, so you'll get a really good feel for how Git works by the end of this.
If you're ever really curious about something, too, just type it into Google a lot of the time.
Yeah, exactly.
You'll figure out exactly what it does. Someone else has asked that question before 99% of the time.
Yes, and we will be using Google on the show as well. Like, I don't know all the answers. Sometimes we think of something cool, and we're like, how do we do that? So,
and then someone else out there.
And guess what? That's what everyone does. Even the people at the big publishing companies, even at like Sony and Microsoft and Nintendo, guess what? They use the internet occasionally.
Yeah.
So C# script. We're going to create a script called gib on trigger is what I'm going to call it. So what this is going to do is we're going to make something explode when we shoot it, when it gets hit by something. So we're going to use a public game object gib. And actually, I'm not even going to worry about that just yet. Let's just make them blow up first. Just destroy them. So all we're going to do is we don't need to start or update in this. I'm going to delete them. They don't have to be there. We're going to use another built-in, though, that it doesn't start with in the project here. It's going to be called void on trigger enter. So this gets called by Unity anytime this object touches another object that has a trigger if they have the proper set of rigid bodies and
There's
stuff
some
like
kind
that.
of graph somewhere on the...
Actually, that graph has disappeared from the internet, which makes me sad. Their latest documentation got rid of it, and it was really important on what collides with what. I will have to give you a rundown. Safest thing, give everything a rigid body, even if it's kinematic. And actually, the only thing that doesn't need rigid body is stuff that does not move at all. If you move it in any way in script, you're gonna want a rigid body. Yeah. And I actually didn't know that at first. It's evidently more costly to move an object that has a collider than it is without a rigid body than it is to move a collider that has a rigid body. Yeah, this in the documentation, deep buried in the internet somewhere. So on trigger enter. So this gets called when this object touches something else. So all we're gonna do is destroy game object, which means, so the lowercase game object means destroy the object that this script is attached to. So I'm going to create some enemies, and we're just going to create them as like capsules or something, just so that we have something different looking. I'm going to just create this enemy up here. And we're going to give this enemy a physics rigid body, and we're going to set it to is kinematic. And I'm going to change it so that all of our colliders are triggers. So the on-trigger enter only works with triggers. As I said, we're going to be not doing much physical response stuff in this game, so we're probably going to be working primarily with triggers. Mm-hmm. It's amazing what you can do with triggers, actually. So I'm going to set trigger on cube, on capsule, and on the sphere here. And so our capsule, we're going to put our gib on trigger script on it. And if we hit play, in theory, if we shoot this thing with our bullet, it will disappear, but it didn't.
You did not.
Sweet. I love it when things don't work. So, okay, definitely looks like it's in line with our spheres. So let's see what happened here. So our capsule has give on trigger. It says on trigger enter, destroy game object. Okay. And we have on our sphere, it has a rigid body kinematic. It's set to a trigger. Okay, this is looking pretty good. It's a little scary. Let's see if it's because our bullets are actually moving so fast that the collision is not catching them.
That is
so
very
let's
possible.
just set it to like 10. Let's make a... I don't think that's actually the case, but let's find out. So we're going to shoot... Nope. Still not working. It's okay. Things don't work all the time. So what we're going to do is on trigger enter here, we're going to find out this is being called. We're going to use a function called debug.log. We're going to say we got here... Generally, you want to be more descriptive than that, but since this is our first debug log, we're going to let it slide. So we hit play, we shoot, and it totally worked and died.
Yeah.
I must have not hit save. I think that's what happened.
Something like that.
So what probably happened was we made these changes to destroy, and I hit save. So I'm going to get rid of the debug log now. Save. And we're going to hit play, and it's probably just going to work now. Yay, it's working. Yeah, good. We just didn't hit save. Let's see if it works on the fast speed. Keep in mind, the speed does matter. So, like, especially if we're doing triggers.
There is a theory. In theory, your object could go so quick that it completely misses the object.
On one frame, it could be here, and then on the next frame, it could be past it. And then it will not make a trigger. There's ways around that using... with real rigid bodies, you can actually do continuous simulation, which can kind of fix that, but there's still cases where the highest speeds cause problems. This is actually one of the biggest problems in racing games, believe it or not, is collision. Collision in racing games is difficult. Getting it just right, getting it to feel right, and getting it so that things don't just clip through walls or clip through things that you don't want it to clip through. So we're going to hit play. We're going to shoot, just see how it's looking. Yeah, looks like we killed it. Cool. So finally, we want this thing to blow up when we shoot it. So let's create a particle effect. These are fun. So we got a particle system here. Default particle system looks kind of lame. It's like a showery thing, but it just kind of goes up into space.
Lame,
they should make it a firework. They should make some really cool, just like so that you don't have to change these things every time that you want.
The only
something.
thing that I made in the way of particles for my... Well, I know I made 2 particles for my game back in the day, but one of them was fireworks.
Excellent.
Yeah.
So we got this particle system. It does things. So I'm going to change its shape here. We're going to make it a sphere. We're going to have it go from a radius of 0 so that it just comes right out of the center there. So it's just basically a point, really. And what are we going to do with this thing? We're going to... so right now it's looping. We don't want it to loop. So we hit stop and hit simulate. And actually, I'm going to probably put the loop back on just so that we can see it running while we're working with it.
All right.
I don't know. We'll see what we do. So we can set the emission rate so we can do like 100 and it'll emit much faster, or we can do like 1 and it'll be very lethargic. Our explosion is kind of instantaneous though, so we actually don't want it to emit at any rate. We want it to be 0, but we want it to burst at the start. So we're going to just make it explode right at the start. See there, we already have something that's looking more like an explosion.
Yep.
The default particle is alpha blended pre-multiply. I actually like explosions to be additive, so I'm actually going to create a new material for this. We're kind of jumping around. We're going to do things as we need to do them. There is a lot you are going to learn on this show, from Unity to version control to everything. It is a lot to take in. Rewatch the show if you need to. Do research. Take the big words I say. Like when I say quaternions, you're like, that's a word I've never heard before. Type it into Google. Start learning this stuff.
Yeah, quaternions is kind of a steep one.
That is a steep. When I say rigid body,
yes,
that's and put Unity in there too, because there's a huge community out there. That's part of the reason I like Unity. That's actually part of the reason I didn't use Perforce, honestly, for this. It's because Git has a huge community out there. There's a lot of people out there that will tell you what to do on Git.
Oh, really?
On Perforce, you'll almost always end up on Perforce's own pages because there's not a lot of public knowledge about it. It's almost what every, shouldn't say every, most big game studios do use Perforce.
Yep.
But version control is version control. What you learn in one thing will pass over to the other, and you're going to learn all of them. I guarantee you, if you become a game developer, you're going to know SVN, you're going to know Git, you're going to know Perforce, and you're going to know like 5 other ones that come out 10 years from now.
Yeah.
So, stop. All right, so actually simulate whatever. So we want this to move a little faster, so we're going to just set the speed to be like 10. So let's see how that goes. All right, that's still not fast enough. Let's make it 50. That's too fast. Let's do 25. Not 256. All right,
Boom.
That looks good. And we don't need it to go for that long, so let's just make it like a 0.5 second lifetime. And let's actually make the lifetime 0.5 as well. And I want it to be a little bit thicker, so let's make the particles, make it 100 particles. Let's make it a little slower, back to 15. That looks kind of like an explosion. And let's change the color around. Let's make it a little bit colorful. Let's do yellow. And final detail, let's actually make the speed shorter again. Let's do 10 and make the duration a little bit longer. You could tweak this forever, honestly.
Can, yep.
0.75. All right, cool. We've got a kind of an explosion thing. And I'm going to create a new material. So materials are what are used to render it. The cube and the capsule and the sphere are all using the default diffuse material. We can change that if we want to. Right now I'm just going to change it on the particles here. So I'm going to create a I'm going to call it additive particle. Additive particle. Because quite frankly, it's not specific to this explosion. We're probably going to be using it elsewhere. We're going to choose the shader. We're going to change the shader to particles additive. And so now if we go to our particle system and we go to the renderer, you'll see that it's set to default particle. If we put in additive particle here, it will be totally awful because we didn't actually put a texture on it. So I'm going to actually use the default particle texture. And it's additive, but it's just not getting enough white out of here. I guess additive really doesn't do much if you only have one color, does it? So let's do I'm not going to worry about it. Let's just do that. So I'm going to save scene, save project. I'm going to call this particle system. You can rename these things. We haven't been doing that, but you can. We're going to call this explode. And we're going to create a prefab of it. And I'm going to delete this one in the scene. And our prefab, before we forget, I'm going to turn off looping.
Yeah, I was just going to bring that up, actually.
And while we're at renaming things, let's call the cube a player, even though that's a stretch. Let's call the capsule an enemy, even though that's a stretch. And let's call the sphere a bullet, even though that's a stretch.
Yeah. Well.
So we're going to hit play, and we're going to shoot, and nothing's going to happen because we didn't change the script yet.
Nope,
so
not yet.
What we want to do now is on our give on trigger, we're going to make it so that it puts something in the place of the character when it dies. And if you make it as an explosion, it'll look like an explosion. So
yeah.
Public game object gib, or jib, I don't know. It's probably jib, but I always use gib. I don't know.
I think it's jib because of
giblets, yeah.
Yeah, but I like saying gib.
I like gibs because it looks like gib when you just type it alone. It's so alone. All right, so we destroy the game object, but before we destroy the game object, honestly, we could actually do this after because destroy doesn't actually happen until the end of the frame. Mm-hmm. But I like to put it at the end so that you know you're done with this object. So we're going to instantiate our gib. I don't know why instantiate is red, but whatever. And we're going to put it at transform.position. This is going to be very similar to our shooting script. And we don't actually care about the rotation, so I'm going to do quaternion.identity. This is code for we don't care.
Yeah, whatever rotation you're at currently, that's the rotation I want, is what that says.
What this means is actually it's the world rotation. It means it will be aligned. It'll be 0, 0, 0 in all rotations.
Oh, nice.
Yeah, that's what it means. So we're going to hit save. We're going to go to our enemy, and in our gib thing, we're going to actually put our explode here. We're going to hit play. Then we're going to shoot, and our enemy blows up. Simple as that.
Oh, that clone person found a copy of the saved Unity collision chart that was mentioned earlier.
Good.
So he tried to link it in the comments, but it appears YouTube doesn't let you send links.
Yeah,
so
it depends.
Sent it to the Pushy as a private message.
Cool. Appreciate it. Sometimes it lets you put links. I don't know what the rules are. I think if you're Google Plusing it, it lets you put links.
Just type in, like, spell out the dots and stuff like that. You could do
Yeah, probably. So I'm going to create a prefab of the enemy just so that I can excuse making a bunch of them. So we're just going to make a few of them here. And let's put the player a little bit lower on the screen. So we're going to put, like, we're just going to drag him
not
down.
the light, because that wouldn't matter.
Yeah, so we're going to put him down, like, -3. Going to hit play. Oops.
Oh,
I was looking at the wrong direction. It's funny how perspective works like that, isn't it? So I was putting them along the Y. Let's so if we want to rotate these things really quickly, let's show them a trick. We're going to create a empty game object. I am going to which one's the one in the middle here? That one. So I'm going to just actually I'm just going to parent. So this is at 0, 0. We're just going to parent all of these to under the game object, and then we're going to rotate this parent game object along the Y by 90 degrees. So what I just did is I created another game object. I told these were children of it, so they will take any rotation information you give them. And then we can actually just drag them out of it again and delete our game object.
So we've created something just as a means
to move things around. Yeah. So now if we hit play, well, okay. So one of them blows up immediately. Did you see that? That was cool. That's a cool bug. So that's probably because I probably have 2 there. I do.
That's
Let's move that one over there. So right now
they were colliding with each other.
Yeah, they were colliding with each other. So now we can shoot these things and they all blow up. Yay.
Neat.
So I'm going to save scene, save project. Let's organize the project a little bit. We're going to create some folders. I'm going to create a folder called scripts. We're going to throw all our scripts in there. Oops, not the scripts folder itself. And I'm going to create a folder called prefabs, which I don't want in scripts. I want that separate. And we're going to put our prefabs in there. And we only have one scene and one thing, but we can make folders anyway. So we're going to make a folder called materials. Put our particle material in there. And we're going to create a folder called scenes. You might also call it levels. We sometimes
you can call it whatever you want to.
You really can call it whatever you want to. You could call it Bob.
Yeah, you could call all of these things names. Whatever naming convention you have is, as long as you can remember and work with it.
Our last order of business is we're going to check in all our changes. You'll see that there's some things here. So these minuses, these files aren't here anymore. What gives? It's because we actually moved them. And we'll actually know it's a move once we stage them, but right now it's confused. And then we have these question marks. These are all files I don't know what to do with. So that means that those are going to be added. So if we just select all of these and drag them in, it will figure it out. And you'll see that it has added materials, added these meta files. It moved bullet. Like, it's smart. It's pretty cool. It moved shoot, and we got rid of test scene 1, but then added it here. I guess the scene was so different that it just didn't believe that it was moved. Which is fine. It's fine.
Yeah, it probably was very different.
So we're going to commit, and we're going to say in enemies explode. Push commits immediately to origin. Commit.
Oh, there's that Unity. Let's see this.
And
very good.
I would say that is a wrap-up of our show for tonight. So thanks for watching.